we have ever played with these metallic pieces that seem to magically attract metals. They are used to make motors, speakers, doorbells, compasses, to close the refrigerator door, and even to make levitating trains. These stones were discovered in ancient times in a region of Turkey called Magnesia, inhabited by the Magnesians, in a Greek village, which is why they were called magnetos. However, nowadays these stones are called magnetite. So magnets, whether natural or artificial, create a magnetic field around them that is capable of attracting certain metals without touching them, even when there are other objects or a vacuum in between. If you conduct an experiment with iron filings, you can make this field visible. As you probably know, all matter is made up of atoms, and within each atom, there are electrons. Each electron acts like a tiny magnet. It has a spin or a direction in which it rotates, which gives it a north and a south pole. As a result, it creates a microscopic magnetic field. So, if the electrons within an atom were to align, they would generate a stronger magnetic field. However, most elements have all their electron shells filled, forming pairs, which cancel out each other's magnetic fields. Therefore, not all elements can be magnetic. That's why Mercury, for example, cannot be magnetic because all its electrons are paired up. On the other hand, chromium has magnetic atoms, but they align in an alternating manner, so they do not cooperate to form a stronger magnetic field. Additionally, for atoms to align, they should not be too hot. That's correct. The only materials that are permanent magnets at room temperature are gadolinium, cobalt, nickel, and iron. And yes, magnetite, which is commonly available for purchase, is indeed made of iron. Also, other substances can be magnets, but they need to be at very cold temperatures, which is why the threshold is called the Curie temperature. But why aren't all objects made of iron magnetic? Because each iron object is composed of sections called domains, and generally their atoms are oriented in different directions. But if you subject the object to a very strong magnetic field, one of the domains prevails and the others align with it. And that's how magnets are made. Currently, the most powerful magnets in the world are made using an alloy of neodymium, iron, and boron. Their crystal structure enhances the alignment of magnetic fields, making them so powerful that if a part of your body were caught between two of them, it could fracture or even puncture it. So, the magnet will have a north pole and a south pole. What would happen if you cut it in half? Would the magnet have only one pole? You might be wondering about this question, but no, the poles are not two parts of the magnet, but rather the direction in which each domain, atom, and electron are aligned. If you divide it, you get two magnets with their respective poles. Like poles repel each other, and opposite poles attract. Another way to create a magnetic field is by passing an electric current through an iron core. This causes an effect explained by the theory of special relativity. The distance between the moving particles is different from that between the stationary particles depending on the observer's position, which results in a difference in charge and thus a magnetic field. Why do the tiny magnets that are electrons create magnetic fields with the property of attraction or repulsion? The truth is, it's one of the great mysteries of science. We only know that it's one of the ways in which quantum effects manifest in our everyday world. Did you know that the word aimant comes from the French word aimant, which in turn comes from the Latin word adamant, meaning invincible? If you like the video, give it a like, share it, and subscribe to the channel. If you want us to discuss a specific topic, comment below.